Okay, so this video is going to be an explanation of the following problem. The problem states that let R be the region bounded by the graphs of y is the cube root of x minus 3, y is negative x squared plus 8, and the y-axis. So that would give us the region right here, because this is negative x plus 8, and then this is the cubed root of x minus 3, and this is the y-axis. So this region right here is what we're going to be dealing with. Um, so the first part of the problem is that we have to determine the area of the region. So this is how you do that. So it's the integral from 0 to 2.907, and those are the limits of integration, and you get those by setting the cubed root of x minus 3 equal to negative x squared plus 8 and solving for x. And you end up with two answers. You end up with 2.907 and negative 3.135. And when you look at the graph, since they meet to the right of the y-axis, that means that the negative 1.135 isn't right, so it's obviously 2.907. So that's how you get the limits of integration, and those are for each part of the problem. Okay, and then so to find the area of the region, you take the uh, upper curve, which would be the negative x plus 8, and then you subtract from it the lower curve, which is the cubed root of x minus 3. So that's what we have up here, and then you put it into the integral, and then it's dx, and you solve, and you end up getting 18.2808. So that's the area of the region. And then the second problem is to determine the volume of the region when you revolve it around the line x is negative 3. And we're going to use the shells method to do this. Okay, so this is the region, uh, a picture of what the region would look like when you rotate around the line x equals negative 3. So you end up with a hole in the middle, which is why you can use the shells method. So the shells method is 2 pi, and then you do the integral from 0 to 2.907 again because it's going from the same spots. And then the first part of it will be the radius, and the radius is from x, which is like a random spot in the region, to the axis of revolution. And since the axis of revolution here is negative 3, so you take x and you subtract negative 3 from it. And then you multiply that by the height, which is this section, or this spot right here, minus this spot down here. So then which is right here. So then you take the upper curve again, which is the negative x squared plus 8, and then you subtract the lower curve. And then you plug that into the integral, and you end up with 470.426. And that's the volume of the region revolved around the line x is negative 3. So the third part of the question is to find the volume of the region using equilateral triangles as your cross sections. So to help us with this part of the problem, I have this equilateral triangle down here, which is sort of close to what it would look like. And you take the regular equation for finding the area of a triangle, which is the area equals 1/2 the base times the height, and then the base would be the right here would be negative x squared plus 8 minus the cube root of x minus 3. And then the tricky part is to find the height. So because you can split the equilateral triangle into two right triangles, you can use the right triangle property right here to find the height. So since the height is the square root of x in this, or sorry, I apologize. This picture down here is actually incorrect. Just this part right here. Um, to find the height. It would actually be x times the square root of 3. Uh, so you already know x, or you know x because since you have the base, which is 2x, then you can the uh, find x by dividing the what you just used for the base by 2, and that would give you x. And then since the height is x multiplied by the square root of 3, then the height would be the base divided by 2 multiplied by the square root of 3. And since that's a constant, and so is the 1/2 that you require for the area of a triangle equation, then you can move both of those outside of the integral. And then the integral would be from 0 to 2.907 again, and then you put in negative x squared plus 8 minus the cubed root of x minus 3 for the base, and negative x squared plus 8 minus the cubed root of x minus 3 divided by 2 for the height into the integral, and then you plug that in your calculator and you get 59.421 for your answer. So that's how you do this problem, and I hope it was helpful.